Okay, today we're going to talk about something called the fundamental identity of trig. Fundamental identity of trig. And before we actually get started, what I want us to recognize is when we're using a calculator, because we're going to use our calculator a bit today, we have to make sure it's in the right mode. We talked about using degrees and we talked about using radians. You have to let your calculator know that you are either in radian mode or degree mode. So if we look at our examples down here, it says use a calculator to calculate each function value rounded to 4 decimal places. So our first one is a sine of 4.27. Now note there is no degree symbol. There's no degree symbol, so we are talking about radians. So now we have to tell our calculator that, hey, I'm in radians mode. When I plug in this 4.27, I want to make sure you're going to understand it's radians. So what we're going to do is we're actually going to go to our calculator. Here's my calculator. Let me actually get out of here so we can see where I got from. All right, that did not quit. There we go. All right, so your screen would look like this if you turned on a Texas Instrument. Whatever calculator you're using, all you need to really do is you need to find your mode button. And your mode button for here is right at the top right near the middle. Let's see if I can highlight that real quick. So all I did is I hit this button right here. That is your mode button. So we're going to hit that, and it's going to bring up this screen. And we scroll down 3 things. It's going to say radians or degrees. Currently, it's in radians mode. If you hit over to the right and hit enter, you're going to be in degree mode. I do want to be in radians, so I'm going to go ahead and re-put that in radians. Now, the 2 ways to get out of this is you can hit that second, which is the top left, and that mode button again, which is a quit about it. So second quit, or you can go ahead and just hit clear. I usually just do that clear button because I don't have to do the second quit. All right, now we're back to where we started, and we're trying to do sine of 4.27. So once again, let's look at where our sine button is. Let's see if I can highlight that as well. Our sine button is right here. Cosine and tangent. Those are the 3 buttons we need for trig. So we're going to locate our sine button, and we're going to go ahead and hit it. So I'm going to hit sine. You're going to see it already comes up with a parenthesis. We're going to type in 4.27. If you look right above the 9, there's a closed parenthesis. We're going to go ahead and hit that. We know in radians, so whatever we pop out is going to be our answer. So our answer right now is negative 0.90373152214. If we go back up the directions, it says round to 4 decimal places. So let's go back to that. Let's see if I can bring it back up because it kind of kicks me out when I do this. We're going to say that sine of 4.27 is actually going to equal, with rounding, negative 0.9037. Those are my 4 decimal places. All right, we're going to do the same thing for cosine, except now we're going to notice it's in degrees. So we're going to make sure our calculator is in degree mode. So I go back to my calculator, I hit my mode button. I'm currently in radians, so I'm going to scroll down, and I'm going to go to degrees, and I'm going to hit enter. Once again, either second quit or clear. I'm back out. Now we're going to hit our cosine button, which is right next to our sine button. Make sure when you're using your negatives, make sure you are using this for your negatives. Don't use this for your negative. You have to use this as your negative. The other one is subtraction. This one is telling the calculator it's a negative number. So we are going to type in negative 39.46. And I'm going to go ahead and hit enter, and we come up with 0.772068. But we need to round to the 4th decimal place, so it's really 0.7721. So let us go back real quick. Got to go back to it. There we go. And we're going to say cosine of negative 39.46 is going to equal 0.7721. All right, so that's how we use our calculator. Just big thing is make sure if you're in radians, you're in radian mode. If you're in degrees, you're using degree modes. It will be forgotten, but I'll keep reminding you. All right, fundamental identity of trigonometry. Fundamental identity of trigonometry relies on this thing called the Pythagorean theorem. Remember from a couple of days ago when we talked about our sine and cosine, we were actually using a right triangle on our unit circle. Well, that right triangle is still there when we make a point, and so we can talk about the Pythagorean theorem. Now what the Pythagorean theorem says, a squared plus b squared equals c squared. Remember that. remember a squared plus b squared equals c squared because we're going to apply that to our unit circle. Now, a quick reminder, this is what we had for our circle. We said once we have our unit circle, we can come up with any triangle that looks like that, where we have one base that's x, our other base is y, and our hypotenuse is 1. All right, so we go back to our Pythagorean theorem. Our Pythagorean theorem said a squared, actually I'm going to go write that down, we said it's a squared plus b squared equals c squared, where a and b are sides and c is our hypotenuse. Where our hypotenuse is always 1. So we can plug that in as 1 squared. Our a squared is going to be our x value. That's one of our sides of our triangle, and the other one is our y squared. So in short, we're going x squared plus y squared has to equal 1. But now let's remember what x and y also were with cosine and sine. We said whenever we find our x value, we're also finding our cosine of that particular angle. When we find our y, we're actually finding our sine of a particular angle. So when we're thinking x squared and y squared, we should really be thinking about, is a cosine of an angle, and we should be thinking about sine of an angle. Our fundamental identity of trigonometry is just plugging in our cosines and sines, which is going to look like this. We're going to have cosine squared, and we usually use alpha in identities, which this is, an identity, so we usually use alphas. There's no problem if you use theta. No one's going to come yell at you or take off points because you use theta, but usually we use alpha for this. So we have cosine squared alpha plus sine squared alpha equals 1. Just a quick reminder, cosine squared alpha is really the same thing as saying cosine alpha squared. It's just easier to write this way, and that's why we do it. So really we're just finding a value, squaring it, plus the other value, squaring it equals 1. But this is going to really help us get from one to the other. So say I know my sine and I'm missing my cosine value, and it's not one of my unit circle ones. I can actually use this formula to go from cosine to sine or sine to cosine. In fact, that's exactly what we're going to do next. So our first example, just remember that cosine squared plus sine squared equals 1. We have to know it for the next part. All right, this says find cosine alpha given that sine alpha equals 3 over 5 and alpha is in quadrant 2. The first thing I want to point out is this alpha is in quadrant 2. And why that's important to us is because we need to know, we're looking for cosine. We're looking for cosine, and I want to know, is this answer going to be positive or negative when I actually find it? So it says that alpha is in quadrant 2. In quadrant 2, you have all students. So remember our little thing, we have all students take calculus. We're in quadrant 2, so sine is positive. Sine is positive, and cosine is negative. Okay, so when we get our cosine, we better know that it's negative. So if it comes out as positive, we're going to make sure it's negative. If it comes out negative, then we are good. In fact, we're going to come up with both options because we're taking the square root. But let's see that right now. All right, so we are given sine alpha equals 3 over 5. Now, 3 over 5 is not on my unit circle, so I don't know what 3 over 5 pairs up with cosine. If, say, it was sine alpha equals 1/2, we know the cosine would be square root of 3 over 2 because those pair together. But we don't know what this 3 over 5. To find cosine without using a calculator, or in fact we couldn't even really use a calculator, we're going to use our cosine squared alpha plus sine squared alpha just equals 1. Then we're going to take the information we know. We know that sine alpha equals 3 over 5. So we're going to plug it 3 over 5 in place of our sine alpha. It's going to look like this. We have cosine squared alpha, not equals, but plus, we're going to have 3 over 5. Don't forget about the squared, equals 1. Now, our whole goal is to actually solve for this. Actually, not that, but we're trying to solve for our cosine alpha. So what we want to do is we want to simplify, move everything over, and get cosine all by itself. So the first thing we're going to do is we're going to complete this squared action. So we're going to have cosine squared alpha plus 3 squared is 9. 5 squared is 25. So 3 over 5 squared is 9 over 25 equals 1. Now what we're going to do is we're going to subtract 9 over 25 from both sides. That's going to cancel out there, and we're going to be left with cosine squared alpha equals, I'm going to change that 1 so I can go ahead and do the subtraction to 25 over 25, and we're subtracting 9 over 25. That's going to leave me with cosine squared alpha equals 25 minus 9 is going to be 16 over 25. Now we're almost there. We're almost there. We want to find out what, let's go back up here. We want to find out what cosine alpha equals. And right now I have cosine squared alpha. It's just like if I said I want to know what x is if x squared equals 9. Well, to get rid of a square, you're going to take the square root of that function. So we're going to take the square root of that side. Well, what I do to one side, I have to do to the other side. I'm going to go ahead and shoot the rest of this over here so I don't run out of room. Well, when you take the square root of something, you're just left with cosine alpha. When you take the square root of a fraction, you're really taking the square root of the top and you're taking the square root of the bottom. And don't forget, we need to include positive, negative. It is plus or minus that square root. So moving forward, we're going to have cosine alpha equals positive or negative. Square root of 16 is 4. And the square root of 25 is 5. Now note we have two options. We have cosine alpha either equals positive 4 over 5 or negative 4 over 5. That's when we go up to our, ooh, that's a bit big. Let's scale that back a little bit. That's when we go back up to our cosine needs to be negative. Cosine needs to be negative, so I know to use that negative version of it. So our cosine alpha equals a negative 4 over 5. Now, if you wanted to check this, you could take that negative 4 over 5 and plug it in for your cosine. And I bet you any money if you do negative 4 over 5 squared plus 3 over 5 squared, you're going to come up with 1. So that is our answer of negative 4 over 5. Let's go ahead and do that one more time. So we are given sine, or we're trying to find sine. So our goal is to solve for sine, given that cosine alpha equals 12 over 13. Once again, I'm going to note that we are in quadrant 4. In quadrant 4, if we're doing our all students take calculus, quadrant 4 tells us that cosine is positive and sine is negative. So cosine is positive, sine is negative. Okay, so our answer is going to be negative, because once again, we're going to square root to both sides, and we're going to come up with a positive negative answer. Let's plow through this one. So we have cosine squared alpha plus sine squared alpha needs to equal 1. But I do know that cosine alpha equals 12 over 3, so we're going to plug that in place of our cosine alpha. Don't forget about the squaring. So we're going to have 12 over 13 squared plus sine squared alpha equals 1. Once again, we're going to finish our squaring, move everything over, and get sine alpha all by itself. So let's do the square. We're going to be left with 144, because 12 squared is 144. 13 squared is 169. Plus sine squared alpha equals 1. I'm going to subtract that 144 over 169 on both sides, minus 144 over 169, so that cancels out. I'm also subtracting it over here, 144 over 169. Now we're going to be left with sine squared alpha equals, instead of 1, I'm going to put that as 169 over 169, but it really is 1 minus 144 over 169. All right, now we're going to have sine squared alpha equals 169 minus 144 is going to leave us with 25 on top. Our denominator is going to stay 169. Now we're going to take the square root of both sides. Don't forget we are actually doing the plus minus. Let's go ahead and shoot that up here so I have some more room. Well, sine squared theta, if you take the square root of it, you're just left with sine alpha equals the square root of 25. Don't forget about your plus or minus, but the square root of 25 is 5 over, and the square root of 169 is going to be 13. Now we have to decide if it's positive or negative. So once again, we go up here and we go, okay, sine should be negative. So I'm going to use that negative right there. So we're going to have sine alpha equals a negative 5 over 13. And that is our answer. Once again, if you're really concerned about checking it, you could do your negative 5 over 13 squared plus that 12 over 13 squared, and that should equal 1. All right, the last thing we're going to do is really just to help you with your homework. There were some problems that were really confusing, and well, let's get out of the way now so you don't have to ask questions tomorrow. You might have questions that say, find the exact value of sine of 4 pi. For theta, where theta equals pi over 8. Well, if theta equals pi over 8, all I'm really asking you to do is to take that pi over 8 and plug it in for that theta right there. We're just going to look something like this. So we have sine of 4 times theta. Well, theta equals pi over 8. So in place of theta, we're going to put pi over 8. Well, that's going to give me sine of 4 pi over 8. Well, that just is sine of pi over 2. Remember, pi over 2 is the one that's straight up and down. In other words, it's 90 degrees. And sine is going to be 1 there. So our exact answer is 1. Just the big step is make sure you replace your theta with whatever they tell you to replace it with. All right, that's it, guys. Good luck on the homework. Make sure you ask questions tomorrow if you didn't understand something.